This is not going a good place. Okay, so we got a cosine of two angles added together. We could add them together and find the cosine, but it might not be pretty. So this would actually be, if you think about it, that's 45 plus 60. That'd be 105. Yep. Okay. But we were told we had to use the sum and difference formula. So make sure you read the instructions on the test and follow the instructions and show your work. Okay. So let's look at this one. If we're using the sum and difference formulas, this is an adding one, and so it's cosine. I'll write the formula down. Cosine u plus v is equal to the cosine of both minus the sine of both. And so we'll call the first one u and the second one v. Okay, now u is a 45-degree angle, right?
For the test, do we have to memorize?
So that's cosine u, cosine v minus sine u, sine v. U is pi over 4. That's 45 degrees, right? So if you think about it, all we're doing here is we're going to find these values of these easier angles and then just plug them in these little spots. So what's the cosine of 45 degrees? Square root of 2 over 2. And you know what? We got to take the sine of it in the next deal. So while we're talking about 45 degrees, what's the sine of that? Same thing. So let's just plug them in. Instead of jumping back and forth between the angles, we can just do it that way. Now, pi over 3 is like 180 divided by 3. That's 60 degrees, right? So what is the cosine of 60 degrees? 1/2, right? A half, because the sine of 30 is a half, so the cosine of 60 is a half. And that means the sine of that angle is, remember it's a half and square root of 3 over 2, and both of those angles have both of those values, square root of 3 over 2. So when you take your test, you might want to make that little chart first, get it straight, make sure you got it, and then, go on from there. I'm not sure. The formula, if you guys, so all we got to do is finish the fraction part of this. Square root of 2 times 1 on the first set of things is, square root of 2 over 4. And then what do we get on the second set of things that we have to multiply?
Square root of 2 times square root of 3.
Yeah, that would be, you can put them together under one radical, square root of 6 over 4. So if I were you, I would just do this, square root of 2 minus square root of 6 over 4. That's the most concise way to write that. If you remember, in one of our sections, we were actually solving things, and we would get statements that look like this at the end when we solved. And a lot of times we end up with a half or something that we recognize, right? Here, we don't recognize these, so what should I think to do if I don't recognize them? They're not like unit circle or special right triangles. Look at the numbers. Do they make you think about anything that...
Yeah, right triangles.
They make you think of right triangles, those Pythagorean triples, right?
Yes.
Okay, now one thing we got to know, and this is in the instructions too if you're not looking at it, it tells us this is in quadrant 2. And they want us to evaluate sine, basically what they want us to evaluate is sine u plus v. Okay, so when we look at this, we know we got a formula. Let's go write the formula down. Let's put everything on our page that we can use to do this problem. We're supposed to use the sum and difference formulas here. So this formula says, if you look on page 380 or in the back of the book, sine u cosine v plus cosine u sine v. So again, what I'm going to do, for the sine, it's plus. For the cosine one where you're adding, it's minus. Yeah. Yes, you might really want to check the formulas. If you think you got them, just check to make sure you got the sign right, because it is a little confusing. Some are plus, some are minus. Okay, so I know that what I'm going to do, if you think about the big idea, what's going on here, I need all these values. I already have some of them. I know what the sine of u is, right? It's right here. It's 5 over 13. And I know what the cosine of v is. This is cosine v. Well, that's right here, too. It's negative 3/5. So I've already got the first set of things filled in just by what they gave me. but I also need to know the cosine of u and the sine of v. Now, you may be able to figure it out without drawing the triangles, but I'm going to go ahead and draw them. If I have, here's the angle here, I'll just kind of dot it for this first one. Sine is opposite over hypotenuse, so that means this side is 12. Now, they want the cosine of this angle right here, so what would the cosine be? Adjacent over hypotenuse would give me what? So I drew the triangle. It's 12/13. Okay, just making sure. Does everybody see that? Y'all just weren't saying it?
Yeah.
Okay, good. Yeah. Okay, that's fine. How about I call on people, okay? That way we're making sure everybody's understanding. Okay, so now I need the sine of v. That means I'm going to have to draw another triangle because I may can figure it out without doing the triangle, but I want to make sure I get the sine right on it. Okay, so here's that angle, V. I'll underline it in blue, so just kind of color coding here. So cosine is the adjacent, which I'll put the -3 down here, and the hypotenuse is 5. And we know this is in quadrant 2. That's going to help us with the sine in a minute. Let's fill in the value first. What is this missing side over here? 4, right? I didn't call anybody, did I? Well, okay. Now, is that supposed to be a positive 4 or a negative 4? Okay, let's see. The sine is quadrant 2, so sine would be positive. Good. Okay, so it would be, what would the value be for sine V? Elizabeth, can you tell me what would sine V be here?
Sine V is 4/5.
Good, 4/5. So now, once I get that filled in, it's just a matter of, getting the fractions multiplied and added together, right? So at this point, we leave the realm of calculus and go back to fractions when you learn probably elementary and junior high. All right, we want to simplify, I guess, if we can.
Is it bad that I really don't know how to multiply fractions together?
Well, when you do it, you just go straight across the top and straight across the bottom multiplying.
How do you get this far?
I don't know. I don't know if I actually ever learned how to do that, but that's simple enough, so now I know.
I could reduce the first one, but if I do, I have to turn right around because I got to have a common denominator. So let's not reduce it, because if you notice, both of those fractions have 13 and 5 on the bottom, right? 13 times 5 would be 65, right?
Oh, yeah.
Yeah, this is kind of in the way. Let me kind of do this. So remember, when you're multiplying fractions, you just go straight across the numerator and multiply. So like on the first one, it would be 5 times -3 is -15. And 13 times 5 is 65. And then on the second fraction, multiply across the top. 12 times 4 would be 48. And 13 times 5 is 65, which is why we didn't reduce it. We saw we already had the common denominator, and we were going to add, so we knew we needed it. Okay, 48 minus 15, is that 33?
Yeah.
Okay, thanks.
Well,
so,
don't trust me. I've gotten 2 things wrong in the past 3 minutes.
It's okay, I trust you. So we'd get 33/65 there unless I've done something wrong there. Okay, so with identities, we always start with the left-hand side, the more difficult side, which I'm just sticking to left-hand side from now on because of that one we ran into in class. Made me paranoid about picking the right-hand side at all. Okay, what do you think we're going to have to do to simplify these? If you think about it, we're studying those sum and difference formulas, right? And this is in a section of sum and difference formulas, so what do you think I probably should do with these two things? Yeah, I'll go look at the formulas and copy them down, because I bet what's going to happen is that's going to be the key to getting it simplified. So if you look at tangent u plus v first, so I'm going to do the first expression. I'll do this one in green so we can kind of see where stuff's coming from. Tangent u plus v. And again, x is going to be like my u, and pi is going to be like my v. That's going to be tan u, which is x, plus tan v, which is the tangent of pi, over 1 minus tangent of both of them, tangent x, tangent pi.
So it says...
So since we're subtracting the other term, I'll highlight it in blue, and I'll write that expression in blue so you can really see where things are coming from here. So u minus v, again, now u is pi in this one, and v is our x. So we're going to plug that in as we go. So tangent u minus v is tangent u, so that would be tangent pi.
Minus tangent x.
Yeah, minus tangent x, all over 1 plus the two of them multiplied together. So it's going to be tangent pi, tangent x. Well, probably stuff's going to get really easy here in just a second. Here's pi. What's that point on the unit circle?
-1, 0.
Okay. Now tangent is y over x, if you remember. Sine over cosine, which would be y over x. I'll put sine over cosine also. So that's going to be 0 over -1, which is 0. So the tangent of pi is 0. Let me go, everywhere I see that, I'm going to put a 0.
I would never do that. I would just, struggle with it forever.
Well, when you see, that's a value, right? Pi is actually a numerical value, and so let's get it knocked out. Let's see what we have left. If we see what we have left, we have tangent x plus 0 is just tangent x over, when I multiply tangent x times 0, that whole term's going to go to 0, isn't it?
Yep.
So I'll just have it over 1 minus, okay, now on the top, I'm going to have 0 minus tangent x, which is negative tangent x. And on the bottom, if you look at this, that's all 0, isn't it? Because 0 times anything is 0.
Does that make this answer non-existent?
No. Because look on the bottom, you have 1 plus 0, basically, right?
What? Because you have 1 minus and then 1 plus.
Yeah, but it's a minus tangent x.
Okay.
So, yeah, that's why you got to be real careful. That this right here, 0 minus tangent x, gave me that negative tangent x. Then I had the subtraction sign, right? Okay, and on the bottom, tangent x times tangent pi was 0, but 1 plus 0 is 1. We have just exactly what we want. This is basically, I'm going to little step it here. Tangent x over 1 is just tangent x. A double negative is a positive,
So it's just 2 tangent x.
which is exactly what we wanted, right?